Dear participants, welcome to the second day of International Summer School on Data Science in Software Engineering. We are very glad to see you again and hope you will enjoy this day and the lecture of this day. We start with a lecture on how to create multi-skill AI assistants enable strategic dialogue management with DeepPavlov. The speaker is Daniel Kornev, Chief Product Officer of DeepPavlov. Hello, Daniel.
Anna, good morning. How things are going on your side?
So I think that we can start because our lectures will be recorded and then uploaded to our YouTube channel. So if somebody miss any information, they can also see it on our YouTube channel a bit later, of course. So we can start.
Yeah, let me try to start. Okay. Hi, my name is Daniel Kornev. I'm Chief Product Officer at DeepPavlov.ai. And today I would like to talk about the problem and solutions for managing dialog strategy in multi-skill AI systems with our DeepPavlov technology. Originally, I presented a version of this talk a few months ago at NVIDIA GTC, and this is the very first time I'm giving this talk for the international audience outside of the NVIDIA conference, and it's a big pleasure for me to share our talk with you folks. Okay, so what I want to talk about today is a few rather important things. And the first thing is, I would like to look at different kinds of AI assistants that we have. And there are lots of different ways how people can actually build AI assistants and AI assistants of very different size and of a very different kind of functionality. Just to give you some sort of an example, if you want to build a very simple social bot or a very simple chat bot, you can definitely just build a skill for Google Assistant, Amazon Alexa, and so on and so forth. And that would be generally just fine. And you will definitely reach some audience, and you definitely be able to talk to people and so on. But while you will reach some relatively large audience, you will have some sort of a problem. And the problem that you will face is a very interesting one. The problem is the functionality of the system that you're going to build will be rather limited. And this is like a reality of what you can achieve with Alexa and Google Assistant. The next thing is, and I think I don't have a good animation for that. And the next thing is, if you want to build something more controllable, something smarter, something more intelligent, you might go into something like Rasa, Amazon Lex, MindMeld, IBM Watson, and many, many other solutions. There are like 11,000 solutions for conversational AI in the market, and you can pick anything about or anything among this space. However, it is important to say one thing, that while there are these two kinds of categories of solutions in the conversational AI space, they are not enough, because our space is so complicated, it's so hard to work in it, it's so hard to achieve really good measurable success. And we believe that there is a question arising lately, that there should be room for a third category of conversational AI systems here on the right. And it should be something bigger than simple skills for existing AI assistants and standalone chatbots. And of course, we at DeepPavlov, we've pondered with this question for years as well. The bar should be pretty high in order to create a new category of conversational AI systems. And those systems are going to have to be far better at doing some key tasks. They are going to be far better at doing some really important things, like they should be better than skills inside the existing consumer AI assistants, and they should be much better than the individual chatbots. And my God, yes. And these conversational AI systems, they should understand the user from multiple perspectives. They should be able to choose from different answer hypotheses, envision users' reactions, dynamically manage dialogue strategy through the use of different skills, and should in general understand user needs better to better address them. And these systems, they have to fulfill needs across multiple domains within which you interact with your customer. You practically have to hide huge complexity, like of this hidden conversational AI iceberg, under this single brand identity. And this means that there is a place for the third category of the conversational AI systems. But if this category should exist, this system should be much better than those individual skills. Otherwise, there is no reason for being. And now some people believe that by simply using the same goal-oriented systems, enhanced with the chit-chat mode and some response selection control, very rudimentary, mind you, they can build AI systems that can serve the needs of the single brand identity, speaking of corporations and so on. But in reality, those systems are still same monolithic chatbots with some experimental features, and they are not good at anything. However, if you're already writing skills by hand or building chatbots with modern systems, you already know that by managing all of the intents, entities, scripts, and so on, it becomes really harder and harder to build this system when their number grows up and when the system complexity grows up. Solving conflicts between parts of your skill or chatbot and your company becomes practically impossible. And that's a real thing. I worked in Yandex in Russia, which built AI system called Alice. And imagining that all of the scenarios would be combined together in one simple monolithic solution, that would be a mess. And you need to divide and conquer different areas, different domains in your system in order to make a manageable system and make it possible to grow the system over the years. Based on more and more feedback coming from users. And it is important that if you want to find a solution to building those smart third category of conversational AI systems, you need to take this into account. You cannot allow yourself to deal with such complexity because you won't be able to manage it. You won't be able to succeed with it. So, what I'm trying to say is the solutions on the left, they are not the solution for a third category of conversational AI systems, and they are not solutions for moving forward with conversational AI in general. Now, we think that we've got something that is. And unlike simple and monolithic chatbots, it beautifully encapsulates all the logic of your complex AI assistant into individual skills. And I'd like to show you today not only how to use it, but also how to use it to manage complexity of the dialog management, to provide your users with a coherent and simple user experience. Okay, so what we have built is entire conversational AI stack. It's our solution for the third category. And it has three major blocks. Our library, which is a library written in Python, but also available through REST APIs, and it has lots of different NLP components. For example, by the way, we have BERT for Russian language. It's a state-of-the-art thing for Russian language today. And we're also working on Distilled. We showcased it like a couple of weeks ago at our community call and so on. There's a lot of things we built in the NLP library, and this is a foundation. But then we have a conversational AI agent, orchestrator, if you like. We call it DeepPavlov agent. And with it, you can actually build complex NLP systems. And then we have DeepPavlov Dream, which is actually our conversational AI platform. There is a repository on GitHub. You can go, and I will provide the link in a couple of minutes and so on. And you can go there and you can clone our repository. Basically, run Docker Compose app build, and you will get your working, very simple multi-skill AI assistant, but it will work. And we are continuing adding new components to the system, like annotators and skills, which I will talk about right in a minute. And you can build your own multi-skill AI assistant on top of our conversational AI stack. So in a way, our third category is like a spiritual successor to Alexa and Google Assistant, because it also is multi-skill, but it's very different. And let me explain why. We get our inspiration not from Alexa itself or Google Assistant. We take inspiration from a frontier kind of idea, like American frontier kind of idea, where you are at the edge, where you have a civilization and have nothing after it. And you're right at the edge, a bleeding edge. And the bleeding edge in NLP is definitely the idea that computers can comprehend human language and they can talk. Thankfully, there is a great competition called Alexa Prize Social Bot Grand Challenge. Amazon is running this challenge since 2016, and there is a fourth running right now, ending like in less than a month. And the task is super complex. You have to create a social bot that can engage in a fun and high-quality conversation on popular topics. And you have to support this conversation for 20 minutes, which is really long. And you have to achieve an average rating of at least 4 out of 5. And as you can see, the last Alexa Prize 3 winners, they got like 3.8 out of 5, which is really impressive. But they managed to last for just 7 minutes and a half. So this is a really big challenge. And why this big challenge is very obvious. You have to support talking about anything, and our civilization is so diverse. The topics we can cover is so large. It's practically infinitum, and you can't cover infinitum with anything you build in technology when it comes to chaos of human conversations. And because of all this chaos we've got, we decided to build our own architecture. Now, all other teams, better to say, like most of the other teams that participate in Amazon Alexa Prize, they use architecture provided to them by Amazon. But we built our own one. As I said before, it's built on top of our conversational AI orchestrator called DeepPavlov agent. And it's a multi-skill architecture. In the nutshell, let me pick a different cursor, something like this. It all starts with the idea that when people say something, we run their query, their utterances, through the lots of annotators. Here you can see the architecture of our Dream Social Bot from Alexa Prize 3. And mind you, in Alexa Prize 4, we've got way more skills, way more annotators in the system. But architecture largely remains the same. And those annotators, they allow us to understand lots of different things about user. So, for example, just for comparison, if you go to a very simple chatbot, you may be able to get some emotional classification, and that's about it. Maybe you'll get intent catcher, and that's a very classical thing, actually. You might get intent classification. But there are so many other things, so many other aspects that you need to have. And usually those smaller solutions, they don't care about this. You might get this, maybe get that, but you won't get the whole picture. You won't get everything. To get everything, you either need to work for Amazon or Google Assistant and work on their solutions, or you have to be in one of our teams, in Alexa Prize teams. And we have this richness of all the different annotators to extract information. So we can extract high-level intents that are used everywhere, like agreement or disagreement, or like asking for whether and other things. On the other side is we can also identify even high-level, more abstract intents that are specific to open domain conversations like Dialog, and I will talk about this later on today. We can do sentence segmentation. So, I mean, like the spoken language is different from written language. We don't exactly have pronunciation marks in our spoken language. And ASR, while it is capable of transforming your speech into text, we need to have some NLP models that can actually segment your utterance into individual phrases, and we use that. And obviously, we have named entity recognition. This year, we added entity linking, which is a fantastic component allowing you to find entities and link them to a Wikidata knowledge graph. So this is just annotators you've got in the beginning. And then we have skill selector. The skill selector component is actually looking into all of the data aggregated by annotators on the previous step and makes a decision which kind of skills have to respond. Now, if you're familiar with consumer AI assistants, which I hope you do, you might know that when you want to interact with them, you have to name a particular skill by their name. And this sort of destroys the whole magic that is lying behind conversational AI. Mind you, in our case, we don't ruin the magic. We hide skill switching behind the system, behind the curtain. And two components are responsible for this. One is skill selector, which actually picks the skills that have to respond to the next step. And the other one is response selector. So once the skills that have been selected make decision and provide a response hypothesis, we run them through candidate annotators, and then the filtered candidates go to response selector. That response selector then makes the decision which of those responses, or maybe a few of them, should be combined together and then sent back to the user. And finally, in architecture, we have response annotators that do further annotation for the generated response that is useful on the next step of the system. So you go from response annotators back to the annotators on the next step. So we have those annotations quite handy. And this is an architecture that allows us to infinitely increase the complexity of the system while still hiding this complexity from the end user. And this way, while with spiritual successors to Alexa and Google Assistant and so on, we are much user-friendlier than they are. Our components are, by the way, available at NVIDIA NGC, so you can go there and grab our components. Our components were specifically trained for NVIDIA GPUs, and we use them a lot in our work. But you can also grab just CPU-based components as well if you like. And we also are available at Docker Hub. So we have like millions of downloads of our base CPU Docker container for our library. Just saying. This is our repository, github.com/dp/dp, where you can actually build, grab it, clone it, and build your simple multi-skill AI assistant. And it's actually built on the same architecture I just explained to you. But if you will start building your multi-skill assistant, you will start facing the problems that we faced. I mean, the whole bunch of our Alexa price teams is facing this problem. So this is like the key problem we all facing. And before we'll dive into the problem, I want to shortly explain how a very simple multi-skill assistant works. Last year, we built a very simple one, inspired by Gertie from the Moon movie. The idea of the Moon movie was very beautiful. There is a man living on a moon base. He is alone there. He has a contract for 3 years, and he has to look after harvesters that collect helium-3 on the other side of the moon. And the helium-3 is then put into canisters into small rockets. Rockets are launched from the moon back to Earth, and they provide energy for thermonuclear reactors back on Earth to power the Earth with electricity generated from the thermonuclear reaction. And there was a small assistant called Gertie. It's a physical one. You can see it in a screenshot. And basically, it's a very simple assistant. It has some functional components like helping with problems. In a way, it's a goal-oriented system. And then you have some open domain components that allow you to talk about anything. And this assistant was very much a poster child of what the assistant should look like. And it was funny, it was engaging, it was smart. And we tried to emulate it with our technology. This is a very simple architecture here. We added just a few components from a big dream chatbot. We added spell checking, we added Nemo ASR, where Nemo is NVIDIA's Nemo library for ASR. We've used a built-in skill selector. We added just a couple of skills. We added emotion classifier to candidate annotators, so it could extract emotion of DP from the system. So this phase would also be available for the end user system. And then we had built a rule-based response selector that basically just looked at the confidences of those skills and made a decision what is the best response to the user, and then provided some small post-processing by embedding emotions into the system and then passing back to TTS and so on. Building such a multi-skill assistant with our technology is rather easy. I've done it multiple times. We all done it many, many times, and it all goes down to a couple of things. First, you have to write down the Docker config. So we have Docker containers for everything, and you have to lay out all the Docker containers you need, like agent, which is our conversation via agent, skills like harvesters maintenance, and program Y, which is the second skill. Then you have to put all the annotators like spell checking, emotion classification, rule, and then you also have to add rule-based response selector if it is an individual component, and so on. And finally, we also have Nemo here, which is ASR from NVIDIA's library. The second thing you need to do is to write down agent pipeline, which is written in YAML, and this one is written as JSON, and it basically represents our architecture, this one. But in JSON, you write down the names of components, you group them into groups, which is like others, skills, annotators, response candidate annotators, and so on and so forth. You specify how you connect to those components. You specify what data you want to provide to the components. For example, for a skill, you can give the entire dialog state, and for annotator, you might want only to give user utterance and so on. You need to control what kind of information you want to get from the system. And you need to specify which component, which method for the orchestrator you need to use at each particular moment, which is more or less obvious when you look at the configuration examples we have in our repository. And the important thing, which I believe is important to stress here, is all the components can be connected via Python or via HTTP. So if you want to have a small contained system and so on, you can use Python. If you want to have a scalable solution with multiple replicas and so on, you can definitely use HTTP protocol, and that's going to be just fine. And that also means you can write down your components in any language you want. You don't have to write everything in Python. You are free to use your Rust or C++, or if you are old school, C, or if you're super old school in assembler, but I have yet to see a REST API service written entirely in assembler. But that's your choice, not mine. Now, a couple more things. To build something in our system, we provide several solutions. One of them is our GoBot framework. It uses Rasa configs, and you actually can build a Rasa-based skill as well. You can build skill in practically any kind of framework for chatbots and so on. And in our case, we just built a very simple goal-oriented skill for harvesters, like what's the status of harvesters, what's the status of particular harvester, prepare logger for trip, and so on. And we have 3 files for that. Our framework is compatible with Rasa. In this case, with Rasa 1.0, and later this month, we hope to ship updated version of GoBot backwards compatible with Rasa 2.0. And you have 3 files. You have to identify intents. for a particular skill, responses to those intents that were recognized. You have to give examples for intents, how those intents look like, because you need to train intent classifier. And you need to have stories that show what response goes after what particular intent and so on. We built this goal-oriented skill server. It has this API called Respond. It's an API REST API endpoint. You basically get a bunch of dialogues, and in each dialog you need to find spelling preprocessing, which fixes some mistakes and so on. Then you generate your utterance response and confidence and provide it back to the system. And that's pretty much it. So you can use a Cobot framework, you can use any other framework you want. You can even write your very much own code. And all you need is to have this kind of endpoint for respond and process the dialogues, and then provide responses and confidences back to the system. And for chatbot, we used IML. It doesn't mean that everything we do in our lab is based on IML. It just was a very simple example. And we just wanted to showcase how to build a very simple multi-skill AI system. So we used IML for our teacher skill. It's very simple. We have like a system profile, the name, place zone, we have greeting scenario, topics, and it basically looks for patterns, picks random pre-generated response, and returns response in confidence. And in the way, well, I'm not going to show a demo right now. You can go and download the build, run Docker Compose app build, and then you can go to your local host 4242, where our agent is hosted. And you need to send a very simple payload, like user ID and the phrase, and you'll get the response. And that's very easy. I run this thing on my Windows machine a couple of days ago on Windows 11, and it was very easy. I spent 20 minutes running the whole environment for Unix and so on for the first time around Ubuntu 18.04. And it works. It's fantastic to have a multi-skill assistant on your own machine. It's crazy because usually you run really supercomputers of sort in data centers for running those kind of things. And this is something you can run on your own machine. But this is where the problems start, not problem finish. And this is why. So yeah, building very simple multi-skill AI systems with DeepPavlov technology is relatively easy. You build skills and you build annotators, you combine them together and so on. But if you want to build something complex, and I hope you're going to build something complicated, something smart, something very intelligent, then you need to know the theory behind how to build those kind of things. In a way, all those AI assistants and our dream AI assistant, the larger one, they build practically the same. You have user query, and then you send it to scenarios. You have a fallback for some kind of search or knowledge base or something like that, and then maybe you have third-party skills. As I said before, in our case, there is no such thing as third-party skills. They are hidden, so you don't know what skill you interact with. You just ask for experience and you get it. But other than that, experience is more or less the same. We don't have Yandex search behind it, or we don't have Google search behind it, but we have Wikidata and OTQA, which allow us to answer factoid questions asked by people. Then it is important to understand that while this picture looks relatively easy, the dialog management itself is complex. Let's take a look at a very simple example. Step one, we need to correctly identify what user's goal is. For example, Alice is asking what happened in City Hall. And a real person would have multiple questions about that, like what kind of City Hall we're talking about, which in NLP is entity disambiguation. Then the user would ask, where it happened. Maybe it's New York City, maybe it's something local, and in the United States, there are lots of places, and all of them usually have some kind of City Hall. And then we need to ask, when this happened. Maybe it's happened today, maybe it's happened yesterday, maybe it happened last week or last year or something like that. Then in the multi-skill AI assistant, you have to generate response. And here we see 3 different kinds of skills that generate different responses. Domain news would say Occupy City Hall happened in July 2020. I have confidence, or 0.85. Then we have factoid skill, which is City Hall is the seat of New York City government, and confidence is 0.95. Then we have some retrieval skill, for example, generated by Reddit. And it says by now 69 City Hall was described as badly crowded because of belly district growing and so on and so forth. The content is 0.75. And back then I said that in this very simple DP demo, we use confidence. But in this case, if we would just rely upon confidence, we would get into unfortunate experience where a user would say what's happened in City Hall and would answer City Hall is a seat of New York City government, just because the confidence for this question is 0.95. So it's clear in a real complex multi-skill assistant, it's not enough to just have confidence as a way to make a decision. And it's quite meaningful if you think about it. At skill selector, you have may have more than one skill to select from, and that means that each skill may also have lots of context. They might be scenario-driven or goal-oriented and so on, and the system has to make lots of decisions at each step in the system. And in the end, you also have a response selector level. And at response selector level, as I said before, we have more than one hypothesis, and we have to pick the best response. And we don't know which is the best response. We can't rely just on confidence. So there's a lot of science going in here. And it's not a coincidence that we built this architecture, because otherwise we wouldn't be able to work with this complexity. And we have some recipes. I would like to talk a little bit about some of these recipes for you today. So in our social bot for the last year, skill selector uses different things like topics and dialog acts. They aid in identifying which skills should be selected. We also use intent catcher. So for example, if user asks, what is the weather like? And in this case, we can identify that actually this is a question for weather skill, and we can feed this information to skill selector. But if, for example, user asks something, and this is not related to any of the few built-in intents, but it's covered by, for example, books, entertainment books as one of the topics we have, and user has a dialog act, for example, asking for opinion, then we can identify that this is actually something for book skill. And for our Reddit skill, because Reddit skill has lots of different responses pre-recorded from Reddit database. And then we pick those two skills and add them to skill selector. Then we built lots of different skills. We have template-based, we have AI markup language-based skills, we have retrieval skills, we even had generative skills. Last year we have some of them this time, but they are not super reliable, so we can't have them move for more like one more steps, because they easily lose context and you can't control it, unfortunately. Even Facebook's Parlay, which is a fantastic thing, their Blender board and so on, they say that the best it was able to maintain context around 7 conversational steps, and then it loses the context. And in the reality, it is even worse than that we deployed one of the systems last year and this year. It's really a fantastic development, but you can't really rely upon it for more than 1 or 2 steps. And then in response selector, after having all those skills, we look at multiple things. We look at toxicity, for example. You don't want to let users see a response that would be toxic for the user. And this could come easily if that response is coming from, for example, retrieval skill like Reddit. We also want to not allow going to user with blacklisted words. For example, user can be elderly, and we don't want to say word cancer. Or, I don't know, it may be something different, maybe religious and so other things. So we want to filter out those kind of hypotheses and make them inappropriate, and then filter them out. And then when we have filtered annotated hypothesis and dialog state and confidence, we also have evaluation scores. Those evaluation scores allow us to understand, like, will this lead to continuation of the dialogue? Will it terminate the dialogue? Is it appropriate for this line of conversation or not, and so on? And we built this complex conversation relation system last year based on lots of dialogues we collected. It's a neural network model. It's not 100% accurate, but it aids a lot in selecting the best choice, making the best choice of the response provided back to the user. And this is actually really complicated. This is where a lot of science comes in. Yes, we have toxicity and blacklist words annotators. And we have this evaluation. But we also write down a lot of handwritten heuristics. We have a lot of handwritten rules, like high priority intents and other things that we also use. We also have penalties, like when Tesla drives a car, they have things that penalize cars. So like if you have a stop signal, cars have to stop. If there is something in front of the car has to stop or change line and so on. So this logic is very similar to what we have. We have these penalties, and for example, we don't want to repeat ourselves to the user if there is a hypothesis repeats itself, so we have to penalize that. And we also add prompts, because if you want to have a meaningful conversation, you want to be more proactive from time to time. So all of these things go into the magic of response letter. And all of this magic, it makes it possible for our Dream Social Bot to be more human-like, more friendly, and caring more about the user, and trying not to bring any kind of soul pain to the user as much as we can do within the framework we've built. But we still have lots of dialog management problems. For example, yeah, we have this final score based on confidence. Yes, it's not just the confidence. There's lots of other components, and we build this formula, final score formula, but it still has its own limitations. Like this year, we used dialog acts in a much broader way than we used in the last year. And for example, our system is, while it's complex and it supports multi-skill architecture and so on natively, it also is single turn based. And you don't want to have single turn based solution because dialog is something that spans across multiple conversation turns. And we also, by the way, have obviously problems with latency, but it's a problem for any kind of solution, especially when you have lots of heavy machine learning models running, supporting the system. Some of the proposals we have are giving priority to multi-turn scripted skills. And maybe finding sequences of dialog acts after dialog acts. So for example, if you identify that user asks for opinion, we have to have a skill that can identify itself as one capable of providing opinion to the user. And this is also tricky. You need to have multiple entry points into a particular skill so that we could react more granular level to the user. We also have problems with context, and that's also something that is challenging for us because you have to maintain context on multiple levels of the dialog. And as I said before, we don't want to rely just on confidence in our solution. Now, it's the last part of my talk today, and I still hope we have like, I don't know, 5 to 10 minutes left. All I've described here is like 3 things. The first one is why there is importance for having certain category of conversational AI systems. And then I explained to you that we built this kind of multi-skill AI architecture, and we experimented with it and battle tested it in Amazon Alexa Prize 3 and Amazon Alexa Prize 4. And I explained to you how to build one AI assistant on top of this architecture. And then I outlined to you how you should actually build one from theoretical perspective, how many, and I showcased to you the pain points of the existing solutions. Now I would like to share a little bit about our vision for where we should go next, where we're actually already heading to, where we believe there is a future for conversational AI. And this requires us to step back and look from bird's eye view at what is the problem we're trying to solve. We're trying to solve the problem of supporting 2 kinds of conversation. A pragmatic one, which is very focused, which is very short, and it's very formal, like order pizza, switch on lights, and so on. And the second kind of conversation is casual one, and it's not driven by pragmatic purpose. It is usually very lengthy, it is informal, it can have a lot of humor inside it, and this is something that is expected from chatbots. It's expected from Alexa, it's expected from Yandex, from Google Assistant, and so on. And this is exactly the problem we're trying to solve. And in reality, even in a casual conversation, you have parts of the pragmatic conversation. For example, if we all would sit in a dinner party and we would sit at the table and talk to each other, at some point, some of you might ask, give me salt and pass me salt, right? And this would be actually a pragmatic conversation because it would be very short, very formal, and then we would go back to the casual conversation. So in a way, casual conversation might supersede pragmatic conversation, it absorbs it. So if you can solve the casual conversation problem, you can solve a pragmatic conversation as well, but not vice versa. And to work with that, we need to understand how to divide and conquer this open domain conversation. Thankfully, there is a language theory that says there are a lot of, by the way, approaches to language analysis. But one of them says, from pragmatics, coming from pragmatics, for example, that there is something called utterance acts, speech acts, and dialogue acts. They come back from Ludwig Wittgenstein, a famous philosopher of the 20th century, the first half of the 20th century, who actually invented the whole speech act thing. And it's like intense in goal-oriented systems, but they're high level. Basically, the idea is that hearer interprets speaker's intentions and tries to interpret desired actions from hearer. So this is the speech act. And dialogue acts, they are working at sentence level. So as I said before, we can transform spoken language into written language by dividing it into different sentences. And dialogue acts allow us to understand the function of each sentence to the entire utterance. There's also the utterance acts that include body movements, but if you build a chatbot that doesn't have any camera, then you can't actually work with this kind of stuff. And finally, at last but not least, there is a large area in language theory called functional linguistics, driven by M.I.K. Halliday, and he invented the idea of speech functions. They are similar to speech acts because they also work at utterance level, but they are focused on how user produces utterance through its role in discourse. Here are some examples. User starts a conversation with open initial discourse move, and they give effect. Then they continue the same discourse by using sustained continue discourse move, and they use like a speech act called like append elaborate. The other user would react to that and provide like a response or rejoinder, and it would like support, and that support would be using a speech act reply acknowledge. And then at some point, another user, like Nate in this case, he will start a new discourse using open initiate, and a new conversation would be started on a new topic. So in a way, you can think the speech functions like a combination of two things: our speech acts from pragmatics and discourse moves. Now, the discourse moves are fantastic. Unlike dialogue acts that are very much specific to a particular sentence in utterance, speech functions, they are part of a discourse patterns. And discourse patterns, they operate across turns. And thus they are overtly interactional and sequential. They're very interesting, and they are basically a strategic mechanism to think about the dialogue. So you think about the sequence of conversation turns as belonging to one particular discourse. And then all the speech functions within it are identifying that they belong to the discourse. And then you can control your dialogue based on the discourse object, not just on single turn speech functions. Here's the example. So at any moment, user can either start a dialogue, start a new discourse by using open move, or they can go with sustain. And in sustain, they can either continue or react. And because every single speech function belongs to only one of the steps, one of the discourse moves, we can always know which part of the discourse we are in the dialogue. And this allows us to actually divide and conquer the open dialogue system and understand what's happening at each step. One of the things we're going to do in the next few months is to add our speech function classifier and speech function predictor to the system. That would allow people to use a speech function classifier to understand the speech function of user set, use speech function predictor to predict what user expects as a response. And one other thing that we are going to build, and one of our new team members started working this last day, is discourse sync that would allow us to understand where we are in the discourse within the whole dialog. And that would allow us to finally have sense of what is happening in the dialog, irrespective of individual skills. And we believe that this kind of metadata would be invaluable for individual skills and for entire system in general, so that the system would no longer base its decisions in the rule-based phase based on just the speech functions or individual terms, but would take into account discourse. It would make decisions whether we have to remain in the same discourse or would we have to move into the next one. And this is our vision for how to tackle the problem of open domain dialog systems. Now, very small illustration. Considering this previous story with like what's happened in the city hall, we can find a speech function and see that it starts with clarify. With our speech function predictor, we would get clarify, answer, and re-challenge for different responses, like those we had in like 20 minutes before. And because this time we understand what is the speech function expected by the user, we can now ask skills to generate responses based on these speech functions. And because we can have this metadata, we can more efficiently control the responses that we give to the user. So in this case, we generate relevant speech function responses. We have those confidences, and we can even predict what the user would say. And this would be useful because in this case, we would also know or have understanding of what might happen after we would provide our response. And this would allow us to not only ignore irrelevant hypotheses, but also to identify where we are, identify what should happen, and control our dialog based on this metadata, which would be impossible to do without having these high-level abstractions. Now, I would love to show you the demo of this thing, but the demo we have is currently working on our internal dialog system that we are developing, and we are not yet ready to show it because Amazon doesn't allow us to show our entire social board to the general public just yet. But after August, like in mid of August, I hope we will be able to showcase parts of our newest system that is user speech functions and so on. And I hope you will be able to come and join and take a look how it works and maybe grab some of the components and experiment with them. Okay, so to wrap up, we have this conversational AI DeepPavlov stack. We've invested a lot of our energy and resources into building the whole thing, coming from NLP framework with NLP components, then building individual skills for it and annotators and so on, and building the orchestration engine. And all of that is built to provide you with an open source platform for building multi-skill AI systems, which are complex, which are intelligent and smart. And if you want to get started with all of this, you can grab our own TP, our simple multi-skill AI system from here. You can join us in Telegram. You can subscribe to us on Twitter. You can ask questions in forum or in Telegram, and you can read our blog. And we would be super happy to share with you our latest news about building open domain dialog systems, our latest news about using speech functions and discourse management and other innovations in terms of open domain dialog systems. And we'd be happy to help you build your own dream, your own multi-skill AI systems with our technology. With that, thank you very much, and I will be happy to answer questions if I still have some time for that. Anna? Here we go.
Thank you, Daniel. Thank you very much. Please don't hesitate to ask questions. It was very interesting lecture. How do you test the system?
Excellent question. So we have something called golden dialog. Golden dialogs, to be more precise. These golden dialogs, they are like a CSV file. In it, we expect questions asked by user, write down questions asked by user, and we write down responses that we expect to be generated by the system at each step. And we run these kind of dialogs against the system as one of the final moves in our Jenkins build process. And if this golden dialog is not running as expected, the build fails, test fails and build fails, and then we have to look into where the problems are. So that's how we test the system if you're talking about testing from software engineering perspective. If you mean human testing, then for Alexa Price, we obviously test on users. That's the whole purpose of the competition. And we also test for ourselves as well. So every skill developer, they run the whole system on their machine. Well, not the whole machine, of course. We run most of the components as proxy on existing bigger development environment, and they build just their own skills on their own machine and then run all of them together, orchestrated locally. And then they just talk to the system and check the system's behavior. There are like 3 ways to test the system depending on what kind of meaning you put into your question. Anna, I can hear you. Your microphone is switched off. Yeah, now it's on.
Thank you, Daniel. Do you see the next question?
How do you split different skills? They seem to be closely related to each other. Good question. So I wouldn't say that our skills are so closely related to each other. For example, we have movies and we have books and we have music, and we try to put specific domain into specific skill. And as long as we put domains into their respective skills, switching between them is more or less easy, because we have topic classifications that allow us to understand where we are going into. And that helps us to pick the best skill for a particular case. The only moment where we have similar skills is when one skill is scenario-driven and the other one is retrieval. But this is where we use our heuristics. We usually prioritize scenario-driven skills where we better control skill response generation than retrieval skills. Okay, I have other questions. What measurements do you take when you test on users? Excellent question. So when we work with Alexa Price, we have ratings that users set to chatbots or social bots, to be more correct. That rating is set by them. We just get ratings from the system like every 1 hour or so. And this rating goes into our system where we can see rating set for each dialog. I don't know, maybe 10 to 15% of all dialogs get ratings. So that's what we have. When we interact with our system outside of it, via website, for example, we have rating set for the entire dialog, and it can be set once or multiple times, but it's still one rating for the entire dialog. Finally, when we provide an access to our social bot or our AI assistant demo and so on through the Telegram, we have a user experience that allows people to rate each particular response, not just the entire dialog, but also each utterance as well. Can you explain the challenges in future improvements of chatbots? That's the next question. The biggest challenge, as I said before, is trying to cover every single topic. The second big challenge is to maintain context. The third is to be able to understand what people are actually asking. The fourth is to understand if our system has opinion about that. The fifth problem is to maintain that opinion to be coherent, or be consistent, which is super hard. And I'm not mentioning everything else. I'm not mentioning things which involve multimodality, where you have to read body language and so on. I'm not talking about multi-language things and so on. But these are very big problems, because you cannot cover every single topic. You cannot easily control context. You cannot easily maintain consistency. So you have to build things around that. For example, for consistency, we are building bot persona skill. And it's something that has persona models based on preferences. And then we use entity linking to find relation to what people say and to persona. And then we use this relation extraction to create opinion automatically based on persona preferences. And then we use it as a way to be consistent. But this also doesn't work everywhere, so it's also somewhat a challenge. And if you can't link into Wikidata, then you have a problem. So lots of big challenges. Okay. Is it another question? Is it supporting to multiple languages? So how we create a chatbot which is supporting different languages? My God, that's a super hard question. So one chatbot doesn't usually support multiple languages. In our case, we didn't have a task to work on this kind of stuff. But in principle, it should not be super hard to do that. I mean, now from architecture perspective, you can build one more annotator that detects language. There are several language detector models available in the market, so we can grab one of them. And once you realize which language the user is asking you can do something. The cheapest way possible is maybe to translate to the language you know, and then use this process and then do backwards translation after the response generation. If you are able to use more resources, you can obviously rebuild the same skills, but for different language and so on. But obviously, this will not be scalable and have multiple languages. And given that language is a very fragile and thing, you would probably want to control language. So you would probably need to not rely on backwards translation and so on. You would probably need to control scenario-driven skills. So that would be a hard task. Okay, and supporting different alphabets, that's different languages like alphabet, the same story. Language detection and so on. Okay, one more question is, you mentioned there is a lot of post-release feedback to analyze and apply for improving the next product version. Can it be called shift right in the software development lifecycle? You mentioned that there is a lot of post-release feedback to analyze and apply for improving the next version. Can be. I don't actually get the second part of the question, Tatiana. But in general, speaking of software development lifecycle, for the duration of Alexa Prize 3 and Alexa Prize 4, we worked and we work on daily basis. So we get feedback and we improve our skills. We have a bugs list channel in our Slack, and we post new bugs into it, and we process those bugs, and we bring fixes every day. So in a way, we are processing feedback coming from users on an everyday basis. It's super hard. It's very exhausting, but it allows us to react to the users. But obviously, not all the feedback we get from users is easy to react upon on the same day. So sometimes it may take days, sometimes it may take weeks, sometimes it may take even months before we are able to actually respond to user feedback. For example, we started with generative skills last year, and then we moved forward with scenario-driven skills, and we had to build something like skill framework for building those kind of skills. And for example, we built a new cool scenario-driven framework, DFF, earlier this year. Sometimes it gets in February or March, and it helped us to build lots of topic-specific skills. And before that, we were waiting for a long time before we could have that. Okay, so I mean more testing on the later development stages. Testing is super hard. Testing in conversational AI, in my understanding, in my experience, not understanding, my experience is really hard. The biggest problem is if you want to have a system with varieties, you will have to adapt to the fact that the system can behave a little bit differently at every single step. And if the system behave a little bit differently, then your golden dialogues would crash. That's problem number one. The other problem is our good skills are usually providing templated responses, but those templated responses can be several templated responses for one single step. It's a scenario-driven skill. And then we have to adapt to those different templates in the system. But those different templates, they're available only to the skill, not to the testing system. So that's another challenge. So in a way, I would say that testing conversational AI systems is an area for good investments. And I hope that we will have better solutions for that. It's really exhausting. I have my personal experience. While I'm a product guy, I built 1.5 skills this year, and one of those skills super hard to, okay, it's 3 skills, almost 3, 2.5 skills. And one of those skills was super hard to bring into the system because when we integrated it with the main branch and run tests, it was very funny to see the test crash. Then you run the whole thing on your local machine and everything works fine. You build there and it crashes. And finding those problems sometimes is really exhausting because when you have a very complex system with many, many moving parts, it's really challenging. So if someone can come up with a better solution for testing, that'd be great. Because I mean, one problem is passing the test, but the other problem is designing test methodology for such a dynamic and adaptive system. That's a big challenge. I hope I answered to you, Tatiana, but I'm not sure. So if you can clarify more, feel free to do that.
So thank you very much, Daniel. Thank you. It was a very interesting lecture and questions, and I hope we will see you someday at some workshop or maybe at school. So thank you very much. And we have a 10 minutes break. We will return to you in 10 minutes with a lecture by Andrey Novikov on data science in the Greenfield, how to initiate analytical projects. So thank you. Bye-bye.
Anna, thank you very much, everyone. Big thanks for watching my talk and for asking such great questions. I think I would love to screenshot those questions at least. They are really, really good. Thank you very much, and have a good luck with the rest of the school. It's a fantastic one, and enjoy the great summer.
Thank
Bye-bye.
you. Bye.
Bye.
Good evening, and welcome to the special edition of Real Testing with Dmitry. You have heard a lot about how the financial industry can make better decisions and run smarter businesses. Amid the geopolitical turmoil and the disruption caused by the recent events, there is one trend that affects every aspect of our lives. And that is the fact that software is consuming the world. What is the one thing that will have the most profound effect on whether this trend is socially desirable, citizen-centric, and undertaken for the public interest? It is our ability to identify defects or conditions that do not meet requirements or expectations in the software before they have a negative impact on people and the infrastructure. It is what the software testing stands for. But do we take it seriously enough?
Who needs testing?
Ouch! We've all seen the destruction caused by the software problems. So why is there a narrative that software testing is not required? Let's take a closer look.
Here's the deal, folks. Software testers have cloaked this industry in defects for much too long. Too much anger, too much fear, too much division. Let me take this moment to say something we don't say often enough. Instead of standing there and submitting defects, why not prevent them? It's not a joke. Who needs more bug tracking systems? We have unit tests. Come on, man! The software works perfectly fine.
Now, let's go to what's happening in live service. Kirill?
Hello, Dmitry. I'm here at the Test World headquarters, where just a few hours ago minor software problems intensified and set fire to a production environment. The visitors of the theme park were assaulted by mostly peaceful androids after their last upgrade. The project team urges everyone to remain calm.
Kirill, do you think that this could have been prevented by outsourcing QA to a specialist firm?
Not sure, Dmitry. Software testers continue to claim without evidence that testing should be independent. Yet research shows no additional value in it. More than 93% of all defects reported by them are not critical. Dmitry?
Thank you. So the question is, should one stick with in-house teams instead? We have a call from the head of incumbent QA to explain how his administration is dealing with such problems. Good evening.
Hi, Dmitry.
It is good to have you with us. Your team barely submit any defects against the platform your developers are working on. Does it mean the software is okay?
It is fine. I don't want people to panic. Managers get upset when there are problems, and I want everyone to be happy. Believe me, we have a huge test management system. It is incredible. We have all requirements stored in it, and we have a test scenario for every requirement. And there is tremendous traceability between them. It is beautiful, and we have no problems with defects because all test scenarios are written before we start the development. It is great.
So your team is also very agile, and requirements change frequently.
They do, but I'm not talking about requirements, Dmitry. They can change totally. I'm talking about test scenarios. They should all be written in advance. It's always a good thing. It helps developers a lot, and I'm going to automate everything bigly.
Thank you. As expected, your colleagues are outraged.
They are always complaining about the lack of test automation, but never about their inability to test.
It's the beginning of the end of quality.
It will never work.
But it has never been tried.
Yes, it has.
No!
Yes, whenever it went wrong, it was because of external
No!
constraints, or because it happened in the wrong place,
No!
or because the wrong people took over.
Yes!
The walls are closing in.
What's wrong?
It's the tipping point. We should not stick to practices that just feel good.
There is nothing wrong with traceability.
Unless it's fake. We need to reflect the true complexity of software under test.
Yes!
It is nice to be around people who think differently than you. They challenge your ideas and keep you from being complacent. Now, joining us from Tbilisi, Natya from Exactpro. Hi, Natya. Are there any organizations out there who support your quest for quality?
Hi, Dmitry. Indeed, there are. We are working with the Global Association for Software Quality to run a national GUI TQB board. As a premium member of the fixed trading community, we have participated in establishment of the MOST working group to develop guidelines for monitoring, onboarding, and software testing. We are also proud to be a part of Zero Outage industry standard. Finally, we are working with universities to create the best practices for testing AI-based systems and with our Headquartered on DLT.
It is good to know that there are people who care about quality. Now back in our studio, we have a researcher from Exactpro. Darya, please explain to us what you do.
Hi, Dmitry, and thanks for inviting me. At Exactpro, we provide independent software testing services to the fintech industry. We build and apply innovative tools and methods to help our clients improve the quality and efficiency of their platforms. With the ever-growing complexity of the software around us, this work is becoming more and more important. You see, most people perceive defects as an inconvenience. We believe that they're valuable pieces of information. Our philosophy and practice are based on this assumption. Our work complements software developers' efforts to prevent defects through early testing. We also help internal QA scale up and automate their processes, identify relevant functional and non-functional defects, and meet their regulatory obligations.
So why do your customers believe your vision?
We work with exchanges, clearinghouses, and technology vendors in 20 countries across 6 continents. We've delivered some of the most challenging projects in the industry that on many occasions successfully went live in periods of unprecedented volatility. We have been a part of the Sybase community since 2016. The Exactpro management team completed an MBO from LSE in 2018 to continue a separate journey as an independent software testing services provider. Our tools support Fix, Swift, and many other protocols and are used globally. Earlier this year, we were named Managed Support Services Provider of the Year by Risk Technology Awards and got an Automation Technology Project of the Year award from QA Financial. Build software to test software is the way towards resiliency. We constantly look for better ways to detect problems and we learn from failure. Software testing is relentless learning. If you want to invest in solving a true existential problem, then software testing for complex, non-deterministic, distributed systems is what you're looking for. Thanks again, Dmitry, for this opportunity.
Thank you, Darya. If you want to learn more about the quality and reliability of your platforms, talk to Exactpro. And that's it for tonight.
You like that?
I do. I'll take 2.
Hello guys, I'm here.
Hello.
So I'm ready to start.
Hello. Let me introduce you. So Andrey Novikov, manager partner of SynData.io, with a lecture on data science in the Greenfield, how to initiate analytical projects. So let's begin.
Okay. Here are my slides. I can browse them, right? Yeah, good. Hello, everyone. So I'm running data science projects in Greenfield for about 6 recent years. And I will try to squeeze some of my experience, maybe several tens of completed projects. And Greenfield is actually a little bit different than what we used to when we talk about data science in telecoms and large banks like Sberbank, MTS, Facebook, whatever. Greenfield, what I call by Greenfield, it is companies, a large number of companies that do not have analytics as a defined business process. Probably they do not have anyone who is called an analyst, but still they have large numbers. They work with data. You know, we all live in the world of data, so anyone can have some benefit from analyzing it professionally. Not only companies can be Greenfield, but business processes, departments can be also Greenfield. Maybe there can be a large company that does a large number of projects, and some of its business processes still lack in being data scientific and being analytical. So I'm working with Greenfield. I've been largely working with Exactpro recent years to start also projects for them and with them. And in this lecture, I will try to share my experience. How do you initiate and how do you run a project to be successful and meaningful? So more or less, this is the idea of what I'm doing in my professional life. I'm trying to make data science and advanced analytics available to companies of all industries and sizes. All sizes, this means mostly medium businesses. They definitely have a place for deeper analytics. And also sometimes small businesses also have an opportunity to develop analytics for their benefit. But first of all, how do the companies benefit from analytics? Maybe some ideas here in the chat if some of the participants type what they think. I'll try to wrap up and answer. Why would a company need analytics? Any ideas from your side? Okay, I have my own answer. First of all, to manage it, you need to measure it. So if you have some business processes, if you drive a car, whatever, you need to see where you are. When you're driving a car, you usually have a GPS, you have a map, or you just have experience of the place, and you already know where you are and where you need to be. But anyhow, you still have some measurements. You need to measure your speed, you need to measure your location, you need to measure the number of fuel, the amount of fuel in your tank, so that you do not run out of it. If you want to manage anything, you need to somehow measure it. And when you're in a business, even if you're in a small or really micro business, you face some number of opportunities because markets are changing, people are coming and leaving the company, customers are changing, and you always have some challenges, and you need to really manage them. So you need to measure. So you need to be aware where you are and how do you deal with it. So this is in my opinion, this is the ultimate answer. Why would you need analytics in any business? But who is you? You need to measure it. Who is you? Of course, you means ultimately the business owner. But when we do analytical projects, we don't work directly with business owners. But in any analytical project, and maybe this is one of the maybe this is the most important slide of this presentation, is when you do a project in analytics, you need the subject matter expert. This is someone who stands in the project on behalf of your business customer, on behalf of the business owner, on behalf of process owner. This is someone who is in touch with the analytical team and who can explain what is important, what is not important. As an analyst, you typically bring some ideas, you bring some data, visualizations, you dig the data and say what you see. But the subject matter expert is someone who can help you understand the business domain and help you understand what is important and help you guide the whole research. So the subject matter expert is absolutely indispensable person in any analytical project you will ever run. On this slide, we see who is the team for analytical projects. So basically, what are the people that you need to run the project? And there are two people. So one of them is SME, subject matter expert, and the second is analyst. This is someone who can analyze data, who can generate insights, who can also bring some industry-specific insights. So, for example, what can be done with data in marketing, in production, in minimizing stock, etc., for many different industries. And analyst is good at data, is good at business ideas, but a subject matter expert can help him understand what is important for the current project. Of course, this can be not two people, but there can be a team of analysts, a team of subject matter experts, and involve people from the client side. But generally, these two roles are absolutely indispensable, and maybe several people in each of them. Okay. How do I browse next? Yeah. And your project is actually communication between these two people. So both of them need to be ready to communicate, and a success of the analytical project is success of this communication, business communication between these two roles. Okay. Once again, to manage it, you need to measure it. But what is it? What ultimately do we measure, and what is meant by measuring? What does it mean to measure? Maybe this is also a question, and you could think about it for a couple of moments. And if you have some nice idea, you can write it down to the chat. The problem is that we cannot measure anything we want. Like we cannot measure the weather tomorrow. We typically want to know if it will be sunny or if it will be rainy. And if you go to vacation to another city, you need to know either it is +30 there or maybe +10, and what clothing you take with you. But generally, you do not need precise measurement. But still, to manage it, you need to measure it. You need to estimate somehow. So personally, I like the following definition. To measure means to reduce level of uncertainty, like for the weather. You need to know either it will be hot or cold. For your car, it is important for you to know either you go at the speed that is allowed at this road, or you're going to receive a fine. So measurement is ultimately a reduction of uncertainty. Okay. Now we know that we need to measure something to reduce the level of uncertainty, but how do we measure it? Let's talk a little bit about what is really to measure. Generally, this is understood in three levels. This is experience maybe of all the analytical companies. Generally, you start from level 1 and you kind of jump to levels 2 or 3 when you are not done with level 1. So I will start my explanation with this first level, and this is descriptive analytics. Descriptive means that we describe something. Like this panel in a car, you want to know what your speed is, you want to know how much fuel you have left in your tank and how much kilometers you still can go before you need to refuel. You also have some indicators that are not numerical, but like status, on or off, like the lamps. Either your lamp is blinking or not, either your handbrake is on or off. This is really a simple dashboard, but it gives you an idea what descriptive analytics mean. It gives you some data that is relevant to you that you really need to know every moment. And at some sense, it is exhaustive. I mean, if you're a driver, you do not really know, you don't really want to know much more. Maybe you would like to add some cabin pressure in your wheels. Maybe you will want to add some cameras around you, but generally this is all. If you are a technician that is trying to diagnose this car, then you'll probably need completely another panel with other measurements, and it will be relevant to another task, to a task of the engineer. So when you design a dashboard, you will need it to be relevant and only relevant data. And this relevancy, it is a large field for customization because things change over time, different roles are present, and what is relevant to you will not be relevant to another role. But if you are making a dashboard, if you are making descriptive level of analytics, you need to figure out what is relevant to your business customer, and that's why you need the SME, the subject matter expert at your project. Maybe this is the most important that we need from a dashboard. By the way, if you have questions or comments, you can type them, and I will try to answer on the go. Other two ideas that we also need from a dashboard is, of course, it needs to be online. The data should be updated as frequently as possible, ideally real time. And the third point is not that obvious, but in a good dashboard, data can be not only data, but then the numbers, the whole structure of the dashboard should be easily modifiable. Why? Again, because we live in agile world. Things are changing over time, and even faster, things are changing in our mind. And we understand, we get new ideas, we communicate with the SME, we communicate with the business, we receive feedback, and we need to change. We need to adjust to be aware of what is going on in all senses that we find relevant at this point. So this is a dashboard. I'll give some simple examples of dashboards. Probably the most simple dashboard you can build in Excel. It is really fast. You can download data. Excel has, the last versions of Excel have nice tools like Power Query that allows you to import data directly from a database, from MySQL, SQL, whatever. And you can analyze them in Excel. You can build some numbers, some graphs also. And what is interesting about this dashboard is that it also has buttons. These blue fields are buttons actually. And if you press a button, it gives you a drill down. You drill down to another sheet of the same Excel book, and it can give you some details, some graphs, some maybe tables to help you better understand. So if you are really new to a project, if you want to build a proof of concept, or you want to draw something simple from scratch, probably Excel will be a good tool for you for this case. Of course, there are more advanced tools that we can also use. One of the popular tools is Tableau. It is a little bit less convenient than Excel because most of people are convenient with Excel, and if you do a prototype here, you can quite easily copy it to any business tool you like. You can give it to a developer, to a programmer, and he will extract the business logic from Excel and transport it to any business tool that they use, maybe to some CRM or ERP or any other business tool. With Tableau, it's a little bit different, and a little bit more difficult. But for making a dashboard that will be business usable, that is also that is also assembled quite fast, Tableau is really good. Maybe you should look at it when you decide to make a dashboard. And even more advanced, but still on level of descriptive analytics, is something like Python, where you can build even more sophisticated things. Like this is one of the projects that we did with Exactpro. This is clusterization. So there is a large number of data, maybe several thousands of dots here, but they are grouped. And a QA engineer in this project would like to see the events grouped to be able to discover what is going on, not a whole bunch of several thousand events, but first of all to divide them to several groups that are alike inside the group. And in these cases, if you are dealing with this level of task, you will find clustering appropriate, and you will need tools like Python. Okay, so concluding this idea of the first level of the analytics of descriptive level, who you will need? You will need, once again, the subject matter expert, the representative of the business customer. Probably this is the most crucial person in the project that you need to have contact with. You need to have an analyst able to analyze the numbers and to come up with any analytical ideas that are present there. On the level of tools, you'll need something like Excel, or Power BI, or Tableau, or Python that can help you build customizable and simple dashboards. Simple, I mean that it can be easily changed as you are evolving in your projects. And then, as you finish your prototype, you can drive it to business, like corporate portal, like ERP, CRM, whatever you want. You can also hard code your model into production code. But generally, you start with something really simple. So I've finished the part of descriptive analytics. Maybe we have some questions here. Okay. Now let's go to the next two levels. Once we have fixed what is important for us, we have built a dashboard like this one. The most important maybe part of this dashboard is that while we construct it, we agree with the SME what is important for us and what is not important. So if you think of weather forecast, you understand that important things for you are temperature, pressure, rain, maybe some magnetic effects, and that's all. Maybe, yeah, wind. You also need wind if you go to some place where it can be really windy, like a hurricane. But basically, this is all that you want. You have fixed some number of KPIs that you will focus on in your predictions in next levels of your research. And predictive analytics is about what will be, what will happen tomorrow, like weather forecast if things go as they are going now. But also here we try to understand what if we change something, what if we push our accelerator in our car, what will be with the speed. And what if analysis is also part of this second level of predictive analytics. One important thing is that you cannot go to level 2 unless you have finished level 1. Why? Because you have agreed here on what is important for you. And you are not judging here what is important, what is not important, because now you are going to machine learning, you go to technical details, and all these basic ideas have been already passed on level 1. That is why you need to, first of all, build some dashboards and try to measure it, and then you try to predict it on level 2. What are the tasks? Actually, a large number of them. Typical task that is always touched at large companies is something about churn. When your customers leave the company, when employees leave the company, it is called churn, and we can predict it. If we talk about banks or telecoms, they're really concerned about churn, and they try to predict when a customer is going to leave them in advance, when they still can do some promo for him, can somehow create his interest once again. And same is true about employees in large companies with thousands of employees. People analyze emails, people analyze communication graphs, reports that employees collect, yearly performance reports, etc. Also to try to guess who's planning to leave the company. A second large idea, actually a really large number of ideas lies here. So these three are just examples. If you work with marketing, they are interested if they give a discount to a certain group of customers, will they buy more? So will this discount pay off? And market campaign prediction is also quite usual example of level 2 predictive analytics. One interesting example is about production companies, for example, food producers. They need to predict demand because if they produce too much, the products will get spoiled because they have finite time that can be kept in stock. If they produce too little, then they will lose some profit. So demand prediction is quite important for them. One more technical example is task duration. So if you're in a technical process like in an exchange, if you have some recurring tasks that are going on from time to time, the duration of this run can be predicted, and we'll have a separate session of them, I think, tomorrow with Maxim Nikiforov, who will share his experience on this specific task. And I think it's really a very nice and interesting project from business and machine learning point of view. Actually, lots of examples here can be named. And when you talk to people, to someone who is not in machine learning, who is not in techniques, when they talk about machine learning, usually they mean predictive analytics. So whatever people are generally talking about, like machine learning, probably this is mostly in the field of predictive analytics. Who do you need? Who do you need for this project? Still an analyst, still a subject matter expert, but here generally you require some knowledge from the field of data science, and you need a data scientist to build all these regressions and machine learning experience. And how do you do it? Normally you start with regressions, where you try to understand. Normally you start with exploratory data analysis and with correlations. And when you try to understand how this data that you have is correlated within itself, what data do you need? Then you try to build some regressions to start predicting part of data from another part. And then you finish up with machine learning when you build models. And this is what the ultimate answer is. This is about the predictive analytics, really a couple of words, but if you have some questions, please post them in the chat. Another important thing that I would like to say here is that if you try to dig the data, if you do level 1, if you do descriptive analysis, it is quite probable that you will want to go to level 2. Because if you see the data, if you understand what the KPIs are relevant for your process, the next natural question is how we can alter these KPIs, how we can change the things that we can change, like in that prayer, yeah? God help me change the things that I can change, help me accept the things that I cannot change, and help me distinguish between the first and the second. So on level 2, we try to change some things that we can alter and see what happens. Okay, now let's go to level 3. Level 3 of analytics is prescriptive. Prescriptive means what should I do to get the result that I want? How do I optimize? A really simple example is Microsoft Project or any other tool that is working with Gantt charts, because Gantt charts can be optimized. There are different people who are involved in the project. Every stage takes some time to run, and a Gantt chart can be optimized. Work can be distributed between people so that the whole project takes as little time as possible. And it has nothing to do with machine learning, but still it is optimization, and still it is prescriptive analytics. The other example is one of the projects that I a little bit touched is diminishing the downtime of an ATM. How do we change the spare parts of the ATM that are going to cause downtime, that are going to be broken? We want to change them in advance to reduce the downtime of this Sberbank ATM. So already to go to the third stage, we already need to finish stage 1 because we already know what are the relevant KPIs. And we also need to finish with level 2 because we have some model, we have some prediction of how the KPIs that we need to optimize reacts to the entries that we can do and that we can influence on. Some examples of the level 3. Project flow optimization, this I already covered. When to manage the replacement parts, when to change the replacement parts of ATM. How much food to produce? Yeah, if you are a manufacturer of food, you need to understand how much food you need to produce for the next month, maybe a week. And if you work as a manager of a restaurant, you need to know how much food you need to prepare, how much people will come to your restaurant this or the other day, depending on the weather, depending on activity of maybe touristic hotels around. So lots of data that you can take as input, and your output is how much food you produce. And this is prescriptive analytics because it tells you directly how much you need to do. Okay. To run a process like this, how is it done? Still, it is machine learning. Also, you need to do some type of optimization. It can be linear programming, like in this simple example with Gantt chart. It can be something more advanced, like numerical experiments. And the typical solutions that you have some model trained in machine learning style, and you do a lot of numerical experiments to understand how you should alter the input data to get the results that are optimal for you. Still, you need the 3 guys, the analyst, who tries to understand the business and connect data science to the subject matter. You still need a guy from the business, that subject matter expert. And you need a data scientist, a sophisticated number guy who can do the machine learning. Sometimes analyst and data scientist can be one and the same person, but generally these are 2 separate roles. In most of the projects that I ever seen, you really need a separate analyst. Okay, now we finished with the 3 levels. Once again, the first level is descriptive. When we see what is going on, we squeeze it to a number of KPIs, and we learn to measure them to see how they change. The second level is when we do forecast. What will change tomorrow? What will change if we change something on the input side? And the third phase is optimization. What we should do, how we should alter the input parameters to make things more optimal. These are the 3 stages of the analytical process. Generally, you step them one by one. You can finish on level 1 at some point. You can complete the phase 1, and you can stop. You can make a full stop, or you can make a pause to understand how it is working, and then you proceed to the level 2 and level 3. Any questions here? What would the difference in level 2 demand prediction example and level 3 how much food to produce? Okay, thank you. Good. Nice question. In level 2, you try to predict from where you are. I mean, marketing guy tells you that I'm planning to give such and such discounts, and let me predict how much revenue I will get from them, because I need to pass these numbers to production so that they are ready for this increased demand. So on level 2, you are still producing, you're still making a model to predict. This model is entry to the level 3, because after you get this model, you want to make some number experiments. and you try to change something. Okay, I will give discount to these people and will not give a discount to other people. You try to score people, customers, by the probability of additional revenue, and you try to really play with numbers. So there is really a gap between level 2 and level 3. On level 2, you still you build a model and you predict from where you are. On level 3, the task is different. You try to optimize. Anna, did I answer your question, or maybe you have some clarifications more? Okay. The second question is, once again, the first. Yeah, Anna.
Yes, thank you.
Good. Someone is typing once again, so I'll make a little bit pause.
So, Andrey, we are waiting for next questions.
I'm going to wait 10 seconds more and then go on. Okay.
How do you think will machine predict a life of a human in future?
I think it can already, because there are examples of data science in medicine, and they produce normally they produce more subtle things. They predict the effectiveness of different drugs. Will this work for you or not? They predict probability of certain diseases based on your DNA. This already works, but probably I'm working in the field of something more grounded, more realistic. If we talk about general future, I don't know, maybe this is a little bit close to what the astrologers do.
Thank you.
Okay, so I think we can go on. I've still several slides left. So we're done with the 3 levels, and now, okay, the customer is asking, should I buy it? Okay, I agree that to manage it, we need to measure it, but analytics can be quite expensive. So how do we understand whether an analytical project is worth investing? And there are three solutions that come to my mind from what we see in our projects. First of all, you start small. You start small with what is really important. So to manage it, you need to measure it. So you take the it that is really important for your business, and that the business will benefit from any input on this side. If we understand from the point of data the process better, then the business will already benefit. So start small. Start small. You can start with simple tools like the Excel or Tableau or something, and you will already have some meaningful result. Use simple tools. Use simple tools that do not require special knowledge. Maybe Excel tools like Power BI and Tableau will be good for start. But if you have someone who is good at Python, Python will of course be also good. And the third is run, stop, think, repeat. The cycle is that from time to time it is good to stop. You stop investing, you stop the work, and you just take time to understand, to reflect on what is going on and on what we have from the previous stages of this project. And if you follow these 3 solutions, at least you can manage the cost of the project, because analysis is expensive and it is beneficial, and you need to correlate these 2 things when you're running a large analytics project. Okay. A wrap up. First of all, you define the business relevant focus. You need an SME, a subject matter expert for this. Then you try to put this focus to numbers. You put it to numeric values, to visual representations, to anything that you find meaningful. You as an analyst and your SME. Then you go to level 3. This is analysis. You do prediction, and then you find things that you can change, and you try to optimize. About the subject matter expert, this is actually, I consider, the most important of this presentation. You really need him, and use simple tools because they also work. Okay, this is mostly what I wanted to tell you today. And if you have any more questions, please don't hesitate to ask them. And meanwhile, I will give a bonus talk on a little bit more on tools. What tool is appropriate for what part of the project? And maybe some tools that you never considered before. The Power BI. Power BI is a free of charge Microsoft tool. They have an online version which is payable, and they have a desktop version which is free. It's really nice. It's a simple tool that you can use to connect to almost any kind of data. A CSV file, an Excel, of course, a database, an online database, a web page from which you can extract tables and data from the tables. Lots and lots of data types that they can import. You have data models that are built semi-automatically. Like if you have several tables, Power BI will connect them automatically for you. If they have same column into tables with same name and same data, it will automatically build the connection like merge. So this is really simple and nice. Use it. And unlike Excel, you have one single button to update all the data that is in Power BI. Excel, I thought of it already, and I told about it. It can build you a little bit more than Power BI, even a little bit more difficult. But where it is good, it is great when you try to hand over prototype, when you try to develop prototypes and hand them over to developers, because developers are at ease with Excel. They can understand it without any additional effort, unlike Power BI, unlike Python. Python, of course, can allow you much more, any clustering, any correlation. And if you go to levels 2 and 3, you'll probably want something like Python, or you can use also Power BI, which supports Python as one of the internal languages. But probably Python itself will be a little bit more easy to start. And the last, and maybe it is a surprise for some of us, is a tool like YED. It is an open source tool that has been developed for recent maybe 10 years. It is there for a long time, and probably it did not change much during the last 5 years. YED helps you build graphs like this. And you need graphs when you want people to think. So if you want to stand with your SME maybe at a flip chart, you will draw the graphs, and it is good to have a tool in your pocket which help you draw graphs automatically. If you have a graph, you can play with a number of representations. So you can play with colors, shapes, fonts, borders, arrows, because they can also be of different colors and thickness. And the arrows can go to one side, to two sides, or no arrows at all. So graphs can contain really a lot of information, and you don't want to use it all because it will be too difficult to perceive for a human. What is good about YED is that it can import graphs from adjacency matrices in Excel. yes, it can import Excel, and you can code in Excel the colors, the fonts, the shapes, whatever, and it can build automatically for you. And if your graph is really large, yet can do the layout. So it can lay out all these vertices on the plane so that it is more or less understandable, and you can play with layouts in Yet much. Also, there are some tricks that can help you embed photos to Yet graph, and you can print them to whatever paper size you want. This is the example of maybe one of the most sophisticated graphs that I ever made. These are people that are working in in parliament in one of the Russian republics. These are peoples with their photographs, with their affiliations to fields of proficiency. Some of them are connected with oil and gas. Some of them are connected with government, with jurisdiction. So people are affiliated to different fields, and in this sense, you can graph people, you can graph business processes, you can graph projects, you can graph data, you can graph modules in a software. So a graph is really a good tool and for visualization and for gaining general understanding with a lot of people. And Yet can build you graphs like this. I've built this one Yet. So that's all that I wanted to tell you today. And you can give me a line directly or through the website if you want to start a new project, if you want to think about a new project or a project that you have. And I'll be happy to help. If you have some other questions, you can also put it here. I think we have still a couple of minutes. And please don't hesitate to ping me if you need any support.
Thank you, Andrey.
Good. Thank you for participation. Happy project.
So people tell you thank you. If there are no more questions, so I would like also to thank you and thank our audience for listening and for asking questions, participating. Now that's all for today, and we will return to you tomorrow. But the program of tomorrow is a little bit changed, so I will send all updates via email and Telegram. So join us, and don't forget to see all messengers. So thank you.
Bye.
Bye-bye. See you.